Hello, and welcome to this video that's going to talk about solving absolute value equations. These will be equations that have one variable, okay? A lot of information on this first slide. I want to kind of just put a little focus here on this idea at the top, okay? So let's see what this says, okay? It says, given the absolute value of x equals b, if b is greater than or equal to 0, x will be equal to b, and x will be equal to negative b. This model becomes decently important for how we're going to attack solving absolute value equations. There's a few more nuances to it than that when you actually get into the problems, but they involve skills that you should have, okay, from your basic algebra. And before I start doing some examples and working through some of these steps I designed, I want to talk about this model in a little bit more detail. So let's actually take a look here on this slide for a second. These three examples where it says the absolute value of x equals 2, the absolute value of y equals 4, and the absolute value of m equals negative 3. Okay? So before we go anywhere with this, let's imagine that we're actually just going to do guess and check here. Okay? So let's take out the letter. I'll just put it here for now. And I'll just run through some numbers here and we'll see if it works. So when we plug in 5, the absolute value of 5 is 5. That doesn't work. Absolute value of 4 doesn't work. Absolute value of 3 doesn't work. But the absolute value of 2 does work. Okay? So I'll just note that where I had x equals here, x equals 2. Okay? But I'm going to continue on because, again, when you're solving an equation, you're not just trying to find a value that makes the equation true. You're trying to find all of them. And it makes sense to explore some of the negative values is here as well, because when you're dealing with absolute value, it's a phenomenon that, has a relationship to its the sign of a number. So I'll keep going and see. Absolute value 1 doesn't work, 0 doesn't work, absolute value negative 1 doesn't work, but we see the absolute value negative 2 does. Again, why? Because negative 2 is 2 away from 0. So I guess I'll realize I've got two answers here in my solution set. X equals 2 and x equals negative 2. Okay? And just basically enough, you could see none of these other numbers work when I put them through here and for where the x was. Okay. So let's take a look here. I'll just replace the x. And then you'll see it seems that if the absolute value of x equals 2, then x equals 2 and x equals negative 2 because they're the numbers that make it true. Now, if you notice, this is exactly what the model says. It says given the absolute value of x equals some number, b, as long as b is greater than or equal to 0, then the x value inside the absolute value bars will be that number or the opposite of that number. So it's not a shock that I said one of the answers for the solution was 2 and the other was negative 2. Okay? So that logic seems to be something that can help me build this model. So let's see if it actually would happen again. Okay? So again, I'm going to take out the y. I'll just put it here. I'll run these numbers through. Okay? Sorry for this slide here. So, and I'll just say true, false, really. Okay, so false, true. Okay, so that's one of my solutions. So I'm getting what? Y equals 4. Continue to kind of pop these numbers through. False, 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 false. And then, wow, that one's true too. So we see that y will not just be 4, it'll be negative 4 as well. And again, if you notice, that looks very similar to this model that we're trying to work with. Okay? So, probably like, I probably didn't need the second example. Okay? Why'd you do it? And let alone why you're going to do a third. Well, this is where this little nuance comes in right here, where it says if b is greater than or equal to 0. Okay? Now, this just happens to do with the definition, the formal definition of absolute value. The absolute value of a number is its distance from 0. So if you say absolute value is, because that's the equal word in math, a distance, you realize that the absolute value cannot be negative. So you're going to realize that the thing that comes out as the output of absolute value will never be negative because absolute value reports a distance for a given number that its input. Okay, so let's just do some guess and check though. Okay, and again, I'll try and be formal about how I say this to start. So I'll say the distance from 5 to 0 is not 3. The distance, excuse me, is not negative 3. The distance from 4 to 0 is not negative 3. The distance of 3 to 0 is not negative 3. And you're like, well, that looks like it wants to work. But if you think, how far is 3 from 0? It's 3, which is not equal to negative 3, even though it looks like it's right. Okay? And if I keep putting all these numbers through, every time I get an absolute value here, it's going to be a positive number, even when I take the absolute value of a negative number. How far is negative 1 from 0? 1. Negative 2 is 2 away from 0. Negative 3 is 3 away from 0. Again, that's not equal to negative 3. So no matter what I put in here, this is always going to be not equal. So in fact, there's no way that I can ever find a number that makes the original equation true. Okay? So in fact, this original equation results in null set. There is no answer that makes that true because this sentence translates absolute value right here is that equal sign before I crossed it out, a distance. And that distance will never be negative 3 because there is no negative distance. Okay? So that's how we're going to build this model that we're going to use. Now we're going to put it to work. But there's a couple of steps that we've got to work with as well. The first one is very basic. It's step 0. I call it step 0 because you don't always have to do it in every problem, but you should always look for it. Now, if you notice, the logic that I built through that model or examined has to do with the fact that the bars, the absolute value expression, are by itself in the equation. Okay, so you have to insist on doing that. We never distribute, just as a point of how absolute value works. And we need to get the bars isolated on one side of the equation. Now, this part where it says think, is this possible, has to do with, are you even getting a distance that is possible, which means the distance has to be positive. If you have a sentence that says the distance is 0 is negative, state null set because it's in fact impossible. Okay? So then you proceed with what we were talking about in the demonstration a moment ago, is you'd be splitting the problem according to this model. Okay? Now in layman's terms, you would sit there and say, okay, it looks like the first time you just recopy the problem without the bars, and the second time you recopy the problem without the bars, but you change the sign to negative. Again, you can only do that if, in fact, the problem is solvable. So you have to think here in this step 1 to know if that's really even possible. And then real basically here, solve both equations. So I'm just trying to give you some steps to give you some structure. But again, the notion that we built here, about how this model works is really where the literacy of solving absolute value functions lies. So I'll do this in order. So we'll isolate the absolute value bars, absolute value expression. So if you notice here, I'm going to subtract 4, and I'll match the colors. That's in red. Okay? And then we're going to get the absolute value of 4x minus 2 is equal to 10. Okay? And then I'm going to say to myself, think, is this possible? Okay? Well, what I'm looking at here is it says the distance of 4x minus 2 to 0 is 10. It's completely possible. Some number I don't know can be 10 away from 0. Okay? So then I'm going to split it according to the model here, which says that that number, 4x minus 2, has to be 10, and 4x minus 2 would have to be negative 10, because these are the two numbers that are 10 away from 0. So 4x minus 2 would have to be one of those numbers. Okay, so then it says solve both equations, add 2, 4x is 12, divide by 4, x is 3. And, now you notice earlier I said the word or when I wrote and. We were saying if the number inside the bars is this or that, as I'm building the solution, it's an and because I'm saying this number and this number are going to be the solution. So the steps are going to be same in both of these equations that I've split, but the result will be different because they're not identical. So this will be 4x equals negative 8 and x equals negative 2. These two answers will be the solution to the problem. Now, I want you to also to notice, because this equation is a little more complex, it's not like we've got 3 to start and we should expect to get negative 3 here. It doesn't work that way. In a multi-step equation, you won't see that. Okay? So let's do another example. Okay? Just check-a-rooney here on number 3. I'm going to work the same steps. Okay? So what's it say? It says isolate the absolute value expression. So I'm going to divide by negative 3 in this problem. Okay? Because that's going to be able to isolate the absolute value expression. Negative 2x plus 4, all in absolute value, is equal to 7. Now, I'm glad this negative sign changed because as I'm thinking about it, it's great because now I do have the absolute value, which is a distance, is a positive value. So as I'm thinking of, is this possible? I say, yeah, it is possible. Now, here's a classic mistake that kids make as well. They sit there and go, oh, I'm doing absolute values, so change a negative to a positive. It's not true. Believe it or not, you're not even taking the absolute value. You're, in fact, just using some logical ideas about absolute value to work your way towards the answer. So I'm going to split the problem because I know it's possible. So I'm going to say that the number inside the bars that I'm taking the absolute value is either 7 away from 0 or that exact number is 7 away from 0 in the other direction. Therefore, that number inside the absolute value has to be 7 or negative 7. So then we're just going to solve both of those equations. Negative 2x equals 3. X equals negative 1.5. You could write negative 1.5 or negative 3/2. Just follow the directions and whatever problems you're doing for specifics about rounding and types of expressions of final answers. Negative 2x equals negative 11. X equals 11/2. These two answers are both my solution set. So x equals negative 1.5 and x equals 11/2 or 5.5. Okay? And again, it makes sense to say these two statements here are joined by and. Okay? Not as important in an equation as when you get to an inequality. When you get to an inequality, the conjunction really makes a difference for the answer. All right, let's take a look at one more example here. It says solve 5m, the absolute value of 5m minus 2 is equal to negative 33. Well, it says isolate the absolute value bars. They are. Okay? So now it says think, is this possible? Well, if I try to read this with a sense of literacy and fluency, I'm trying to say here that the distance of 5m minus 2 to 0 is negative 33. So this sentence, if you really generalize it, it says distance equals negative. Okay? Again, you have to have the bars by itself to be able to apply this logic. And we know that this is false. So quite frankly, M is null set. There is, in fact, no number that will make that true because I will never get as an output to absolute value a negative number. Now, you could actually get 0. Now, I didn't do an example with that, but there is such thing as a distance from 0 being 0. It means you're on 0. So I hope this was helpful. Feel free to practice, share, and I'll probably be constructing another video soon about absolute value inequalities that will be somewhat like this. They're a little more challenging, but you have to have this mastered first and realize that there's a logic that builds a model for both types of inequalities, and those models are used to solve those statements. Okay, enjoy.